I'm going to talk about Grapevine, what we like to call our way of trying to track businesses on Twitter. So Twitter is no longer just a social network. It has a lot of uses in tracking breaking news, tracking live events, and one of the more interesting use cases is in the consumer business sector, where it has seen widespread acceptance by companies in various sectors, not just the tech sectors. This is not surprising because Twitter gives them a paradigm which they're kind of already used to through mailing lists, basically being able to reach out to people who are already interested in them and follow them. Except in the case of Twitter, they can do this with millions of people in seconds rather than sending out snail mail and all those traditional approaches. And they can use this for any number of ways to increase customer loyalty, announcements, advertisements, deals, etc. However, Twitter doesn't make it very easy for these companies to listen to what people on the global Twitter user space are talking about these companies. It makes it easy to talk to them, but it doesn't make it very easy to listen back to what's being said about them. And we kind of define listen in a little more depth. Firstly, it consists of being able to detect who are making relevant mentions of my company on Twitter. We highlight relevant here because Twitter, as a data source, has a pretty low signal-to-noise ratio. Additionally, once I've identified people talking about my company, I want to, what additional information do I know about them? Can I gain any insight about them, which would be helpful for market research? And also on this network where people are communicating, is there any developing story that I need to be aware of that concerns me, positive or negative? This is clearly important for a company because any kind of insight on their users can lead to better market research. And it can, having this insightful information about these users can finally sort of trigger off this social marketing revolution that's kind of been around the corner. But traditionally, it's only been broadcast-based marketing, even on social networks, because there doesn't exist a lot of insightful information, at least on Twitter, and we'll see why that is. Also, it gives companies an opportunity to react quicker to some of these trending and emerging stories that kind of break faster or have been breaking faster on Twitter these days than some of the conventional media sources. And more importantly than just reacting, you're able to get the actual customer reactions and feedback to those stories as they happen, rather than seeing the reactions either explicitly or implicitly through other, say, sales figures or earnings, etc. So why is this difficult? Clearly, Twitter has millions of users, it has all this data, but still it's not something that a company can just easily implement on its own, and that's where we come in. So Twitter does not provide a lot of structured data about its users, which could lead to user insight. In fact, the only thing that it demands of its users when opening an account is a screen name and a small textual description. So there aren't any structured fields for age, gender, etc., anything that a business might find useful. Also, at its heart, it's a social network. So even for relevant tweets that talk about companies, the language used is often very informal, consisting of a lot of abbreviations, slangs, and spelling mistakes, and also ambiguity in the names of businesses, the most famous example being Apple, distinguishing between the fruit and the actual company. Twitter also does not formally provide any context once a tweet is published. The only context you sort of have is the user publishing it. It doesn't attempt to organize tweets into different categories or topics so that you may know and be able to resolve some problems like the ambiguity problem. Hashtags are an informal way by which users try to categorize their own tweets, but there's been a lot of research on the lifetime and life cycle of hashtags, and it turns out that a lot of them are generated quite randomly and quite often, so they can't reliably be used to provide context to these tweets over a long period of time. And again, being a social network, there's a lot of so as we define irrelevant tweets, which are basically about nothing. When we look at them from a business standpoint, they consist of personal conversations, random observations about a user's mood or activity, etc., and a whole lot of spam. And lastly, data from Twitter is huge. It's not something that a company could just import into Excel and try to gain some insight out of it. It requires specialized techniques. This is a graph showing we were tracking 70 companies for this research project, and these are the hourly Twitter volumes received on our end by our collectors, and they are easily averaging out to be above 100,000 tweets per hour, just for 70 companies. So if we build something like a Google Finance, where we track this for potentially all the companies around, then you can just imagine how that data would grow. So this is where we come in. What we've tried to do is first address the noise problem in this data stream to build a relevance filter that removes any irrelevant tweets from the perspective of our use case over here, so that any other analysis we perform further is improved in quality. We also try to analyze data about the users and gain insight that could be useful to a business. We lastly also try to detect stories about a company that is emerging or trending on a network like Twitter. So before we dive into these analysis, a small validation to whether users actually talk about businesses on Twitter, or is it still just purely a social network. So these 4 companies were among the 70 that we were tracking, and it turns out that the numbers are significant enough to give us a lot of good signal about what users might be talking about the companies. These are the daily tweet volumes for these 4 companies during our month-long collection period, and they range from about 50,000 to a couple of hundreds of thousands. The pink bars represent the volume of tweets that were actually retweets, and the complete length of the bar is the total volume experienced in that day. And not only do they talk about businesses pretty regularly, they do so even more when it's negative news that affects them concerning the company. This was an example for Toyota when on April 11th, during our collection period, they issued a notice for one of the biggest recalls they've ever had for faulty airbags. And there was an immediate spike in the tweet volume that day concerning this event. So these are clearly events that companies need to respond to and would be interested in knowing how the customer base feels about them. So clearly Twitter is a good data source to be using for this application. So let's begin with cleaning up the noise, the relevance filter. So again, defining relevance, or what we mean by relevance, a little more clearly. Any tweet that pertains to a company but also is topic-based. So it's definitely talking about something versus being a personal conversation or a random observation. So if someone says that I dropped my new Samsung Galaxy S4 in a pool, it's kind of a personal observation. It's not really meaningful for a business or a company. Whereas if someone's talking about a particular story relating to that company with a link that leads to another article, then it's definitely something noteworthy that we should pay attention to. So that's kind of how we make the distinction between relevant and not relevant. And Twitter releases annual statistics about the different kind of tweets floating around in its data stream on a daily basis, personal conversations, the tweets that have URLs, etc. But since we were collecting a more specialized data set by tracking keywords for these 70 companies, we wanted a more detailed view of how much noise or how many irrelevant tweets exist in our data set. So we actually took a sample of 12,000 tweets from our data set and used Amazon's Mechanical Turk to get other workers to label our tweets as relevant, non-relevant, or being of a different foreign language based on a set of guidelines that we provided. And if you focus on the middle column over here, which is our data set for the company tweets, it turns out that the relevant tweets are actually less than 50% of that data set that we uploaded. So clearly there is still a need for building some sort of relevance filter, in spite of the fact that these are the tweets that are mentioning the 70 companies that we're tracking. So the tweet is just raw text, but we try to extract a lot of features that could help us in building a classifier to distinguish between these two types of tweets. So on top of the raw text, we generated some features like the number of times this tweet has been recirculated around the network, which could be a good indication of whether it's interesting or not. And we also wanted to depict the presence of certain Twitter-specific features like mentions, URLs, and hashtags, and their presence in the tweet to be able to say something about its importance or relevance. Additionally, we also generated an independent separate set of features where we used a Twitter-specific part of speech tagger to examine whether the type of language and the type of language components used in the tweet could say anything about its relevance. So here you get the typical language components like nouns, verbs, and their fractional composition of the tweet, or what fraction of the tweet they make up, basically. So it turns out that the language-specific features do not help a lot. The classification and accuracy results aren't very impressive. But if we look at the Twitter-specific features that we extracted from the raw text, then we are able to get close to in the upper 70s. The classification accuracies that we get are in the upper 70s. And surprisingly, the feature that was able to provide the maximum information gain about relevant or not relevant across the board was average word length, which initially kind of surprised us. But it makes sense because the relevant tweets tend to have more proper nouns, adjectives, and a lot of URLs, which if we simply tokenize tweets on white space result in higher average word length versus what we call irrelevant tweets, which are more casual and have more common nouns, abbreviations, etc. So moving on to our second contribution, where we try to dig deeper and say something sensible about users that's not apparent from the raw data. So we kind of categorize the different things we wanted to say about the users under two broad categories. One of influence, which is more about their behavior and how they tweet and how they get listened to on the network. So that's influence. And expertise is more about the topics that they're interested in or influential in. And currently, in this time frame, we've only been able to focus on expertise because doing influence right would require collecting individual tweets for a large group of users, which is a significant collection effort in its own and can also be a different research topic. So we kind of just wanted to see how users go about mentioning companies. We know that the daily volume per company is large, but how is the per user volume? So it turns out that this is true for all the companies. I've just shown two companies here, that there's a long tail distribution of how many times they get mentioned by a user during our collection period. And we realized that we basically want to focus on, say, the top 10% of users in each case, because the rest of the users kind of blend into the tail. And these top 10 really stand out in their tweet volumes and how many times they're actually talking about this company. So if we were to simply take the top 10% of these tweeters by their tweet volumes, it turns out that that naive way of doing things is not really good, because most of the times the top 10% gets dominated by bots, which are just generating spam, or there are these types of Twitter accounts specifically generated to retweet content from some other place or kind of act as an aggregator. And many times they're the Twitter account of the company itself, which is not really useful to the company. So those were kind of obvious problems that we expected to face. But turns out there's also problems that we face due to ambiguity in the company name, which I was talking about earlier. So this is an example of the top 4 tweeters for Delta Airlines, simply by volume. And this, just looking at it, it was kind of shocking, and it didn't make any sense to us initially. There's an author and 3 hardware stores. But later we realized that Delta is also a brand of faucets for kitchens and bathrooms, so that kind of made a little more sense. But we still had this problem of how do we clean up this list of users talking about the company. So we clearly need some idea of the expertise of these people and what fields they're interested in, and then kind of rank the list according to that and hope for a better result. So doing so explicitly doesn't scale for this kind of an application, because you would have to, again, fetch the individual tweets of all these users and try to detect the topics that they're interested in, and then sort of have a topic profile for each user before you can say whether they pertain to Delta or not. So we try to do this implicitly without having to fetch all that data in by using the nearest neighbors of a company. Our intuition was that if someone is interested or really interested in Delta Airlines, they would also show some amount of interest in other airlines in that other airlines that we're collecting tweets for. So basically, they would show interest in that general vertical that the company belongs to. So we take the nearest neighbors of that company, and we select some threshold that we will only select the users who are also talking about, let's say, K of those companies in that nearest neighbor set. And then we average them, we calculate a weighted average of their tweet volume across all these K companies, and then order the list again. And turns out it leads to a much better representation of who the top tweeters for this company are, because now all of these tweeters are actually about aviation and airlines. So we were able to successfully do this for a bunch of companies, and we get a much better idea based on expertise right now, not influence, of who the top tweeters for a company are. So moving on to our last contribution, which was enabling these companies to detect trending stories about themselves on Twitter. And we revisit the Toyota incident, wherein we define a trending story as content which has not been seen before, so it's novel. And it's also currently being seen in a huge volume, so it's got a lot of support as well. So we realized that we can't simply go by spikes in tweet volume, because that's really random, especially for popular companies. Like if you were tracking tweets for a Facebook or an Apple, we noticed that the spikes in volume alone don't really correlate to sensible, distinct events that you would consider significant in the real-life timeline. So we kind of examined the content of the tweets of Toyota on April 10th, which is above, and April 11th, which is the day the recall was announced. And we noticed that certain words that pertain to the story become really significant. So these word clouds, basically the size in the word clouds indicate how often those words occur. So we realized that our method for detecting these stories should not only consider the volume increase in tweets, but also the change in the content. So we devised a dictionary learning-based approach, wherein we basically calculate a sliding window of the content that we see for a particular company. And this window is variable. It could be minutes, hours, or days, depending on how aggressively you want to track the emergence of these stories. And for each window, we basically calculate the top n occurring words, where again, n is a configurable parameter, and we load them into a dictionary where for each word loaded in, we calculate a likelihood for its occurrence. And we continue to do this per window, and for every window, once the loading process is complete, we calculate the fractional change in tweet content. And if this is above a certain threshold, typically, we've seen that 0.7, if we see a 70% change, then it's pretty likely that it's a trending story about that company. And in this way, we consider both content, because we're looking at the change in the word occurrences, and the volume, because we're calculating the top n words for every given window. So our algorithm achieves both of those, and these are some of the events we were able to detect for our 70 companies during our month-long collection period. And the good thing is we were able to detect a lot of negative events, which was the initial goal, as we considered these events to be more significant for a company to track, and to be able to track user response and user feedback during the event occurring. So to conclude, we were able to build a relevance filter, which is able to classify tweets as relevant or irrelevant with accuracies up to 78%. And not only does this improve further analysis results, it's also a big processing in storage and general processing costs, because we're dealing with tweets in the order of hundreds of millions here in our own data set. We were also able to rank the users talking about a company, not just by volume, which is often erroneous, but also by their expertise, to yield something more meaningful for the company. And we were also able to detect trending stories that concern them with the dictionary learning-based algorithm. Thank you.